Okay, and then is the third problem. So in this problem, you are given two array of length n. The first array is A. The second array is B. You want to split these two arrays in arbitrary k segment. For example, if k is equal to 3, then you can split the two arrays each in k part, and each part should be non-empty, and every element belongs to exactly one subarray. And you need to let AI the number of the average value of AI in the ith part should be less than the average of the value in the ith part in B. And you need to count the number of the split module 10 to the 9 plus 7. And the n is less than 500. So this problem, I think to pass this problem, this is medium one, not so hard and not so easy. And the most important thing is that for this problem, the n to the power of 4 solution is very easy to thinking of. That is using a DP. So let's define DPIJ as a context to split the first I element of the first array and the first J element of the second array, adhering to the given constraint. So, and also let's denote SAI to mean the perfect sum of the first array, and the SB I to be the perfect sum of the second array. Now, how to do the transitions? For dpij, first we should iterate for I prime is less than I, and iterate for J prime is less than J. And it can translate from dpi prime J prime with the condition that SA I minus SA I prime over I minus I prime is less than or equals to SBI minus SBI, sorry, J minus SJ, J prime over J minus J prime. In fact, this is just a restate of the problem statement. If we write the problem statement down in a DP formula, then this is just the result. So I would like to say that the ON to the power of 4 solutions is very easy and also very easy to implement only 3 lines of code. But the problem is how to optimize to faster solutions. And in fact, finally, since n is equals to 500, we need to implement our ON cube solutions. How to do this? We can think that after we decide an I, after we fix an I, then for each J and J prime, then still first, so the first we fix I. And then for each pair of J and J prime, which dp I prime J prime should be transformed to this? That is somehow like the case smallest I prime in value of SAI minus SAI prime over I minus I prime. So if we fix I and we determine J and J prime, so we get the value of these. And then we only need to sum up for the I prime that the SAI minus SAI prime over I minus I prime that is less than this value. So what we can do is every time we fix I, we sort all the I prime by SAI minus SAI prime over I and I prime. We sort it in this way. And we do a prefix sum. We do a prefix sum over I prime dimension. And then we iterate for all the J and then the J prime. And we want to calculate the answer. We just need to get this Sj minus Sj prime over J minus J prime. And then we do a binary search in the I prime dimensions. And we find out the prefix sum of this dp value. So by this means, we can speed up the solution to be n cubed log. But and then how to speed up these solutions into the ON, into our n cubed solutions? We'll find out that if we pretty sort the J, and for each J, if we sort the J prime by the value of SBJ minus SBJ prime over J minus J prime, then we only need to do 2 pointers to find the corresponding positions and no need to do the binary search. So the log in the binary search can be omitted, and then we can easily get n cubed solutions. And that's how we do this. Okay, I think I have finished the short sharing about the problem. And then is the Q&A sessions, and feel free to ask any questions. If there are no problem now, and while you are thinking of problems, I can talk something about this year's USACO gold problems. And the first things I want to say is that the problems are getting harder and harder. I would like to say that usually the second problem, this type of data structures, they are talked about in the platinum level. And also the first problem, it is really hard to think of, and it takes me a lot of time in the context to solve this problem. I think this is not that easy. So, and the second thing is, I would like to see, we can look at these 3 problems, and we'll find out that in the first problem, I think this is a problem that sync is problem 1, sync is greater than the code. And in the problem 2, sync is much more less than code. And in the problem 3, we can think that the sync is a little less than the code, but they are somehow close. And I would like to say that you can find out that in these years, the USACO are more and more concentrate on the coding task. So I think if you want to make your USACO performance better, you can practice more on the code, and you can try to much more enhance your coding abilities. I know that many of you may love to do the problems on the code forces or the coders, and I think that this platform they are more emphasize the thinking part, but not the code part. But if you want to get a good grades in the USACO contest, then you have to really do a lot of practice on the code, how to implement your algorithm to be correct. It is not to say that sync is not important. Sync is also important, but if you know how to code, then you can get better grades. So just pay more attention on coding. Okay, so any questions?
Thanks, Xiting. One question from YouTube audience. Why I think the problem 2 is the hardest one. How can I improve?
Okay. So if you think problem 2 is the hardest, I think somehow maybe it's because the difference of Chinese competitors and American competitors. Maybe because I talk about some of my Chinese friends of this contest, and we think that the problem 2 is easy because maybe data structures are more are talked about more in Chinese. So anyway, so if you want to improve your solving abilities in the problem 2, then yeah, still this. So I think generally the coding abilities is the thing that you need to practice. Now here the coding abilities is not to say I know the algorithms, but how to code this, how to implement this correct, how to implement this in a quick way. It is not, coding is not only these things, but coding is also how to find out a way to adjust these very long detailed talking. You have very long detailed talking here and here. These are two very dirty work. And you will see that the only things you need to know is how to calculate these. And if you ask me, I would say like that this is a very classic. This is a rather classic technique in the segment tree. If you do not know this, then it means that you have to practice more problem on the data structures, and that's it. So make a conclusion. So if you cannot solve problem 2 because you do not know this, then this means that you should do more and more data structures. But if you already know this, but you just do not figure out this problem or face some coding difficulties in these problems, then I would say just practice code and just write more problems, do more problems. And also, I would recommend you to do some problems from the China online judge, and you'll find many practice about the data structures. And do not only practice on the code forces or the coder. These two platforms these two platforms are generally talk about the thinking. but the code, you can try to practice some more on the Chinese online job, and that's it. Could you please write down the name of the website? Maybe just for some algo, lj.ac and uoj.ac. Or okay. .com. You can try to find something in these three websites. Any other questions?
Yeah, no follow-up question on YouTube. Thanks. How
Okay,
about,
great.
yeah, maybe you can unmute yourself and discuss with our coach and lecturer. Let's wait one more.
Sorry. Okay.
Yeah, we can ask the student, yeah, to participate, to unmute themselves and have a direct discussion.
Yeah. Feel free to do so.
Sitting, follow-up question from the same audience. Only finish partial P1. Any suggestion?
Yeah. So for problem one, yes, but the problem one, this is so I think this is just greedy problem, and you know that for the greedy problem, generally we do not have many formula to solve these problems, and it is hardly depend on your insight, whether you can think of a better way to reformulate the problem. For example, whether you can think of how to rearrange the 1 to n into k times n over k grid. So this sometimes need experience and sometimes need just insight. So I think that for me, my suggestion to you is that while in the context face this type of the problem and this type of the greedy problem, and you do not know how to solve this in your first glance, then just throw this problem. through a 3D problem if cannot solve at once. And only come back to it when you solve the other, when you have finished the other problem. Because the graded problem, you really do not know when can you solve it if you cannot solve it at once. These problems are highly depend on your insight.
If there are no other questions, then I think we can end this workshop here. Once again, thank you guys all for coming to this workshop. And we'll be starting Bronson Silver Solutions at 6 p.m. So we can take about a 15-minute break before we start the solutions. Yeah, thank you guys.
Yeah, thanks for listening and see you.
Yeah, and Ryan, maybe we can share the USACO report to all the audience.
Oh yeah, sure. Yeah, let me pull it up on my side. Okay, so XM has this USACO report card that you can try out for yourself. If you go to xcam.org, you can go to the USACO report and you can create your own report card for your scores this season. So yeah, let's see. Right here, USACO report. You can go ahead and fill this out and you get a report on your performance. And then also, SCAMP is generously offering a $100 off coupon code for all students coming to this workshop. So at checkout, you can use the code CPI100 to get $100 off the courses that XCamp offers. Okay, yeah, I think that's about it. Shan, do you have anything to add?
That's all. Thank you all for coming. If student who pass silver or into gold division and platinum division, we also have a coach for one-on-one free consultation. Welcome to consult us. Thank you all.